Hello boys and girls, and welcome to lesson 1-5 on page 26 of your textbook. In this lesson, we're going to be looking at problem-solving strategies, so different problem-solving strategies. Now I want to focus here on this little section, okay? First, using problem-solving strategies. There are many problem-solving strategies in mathematics. One common strategy is to look for a pattern. To use this strategy, analyze the first few numbers in a pattern and identify a rule that is used to go from one number to the next number. Then use the rule to extend the pattern and find a solution. Now, boys and girls, this is very common actually. This is on the SAT test. I'll show you a question from the practice SAT test where you actually need to look for a pattern. Here it is. This question was on the SAT test this year, okay? So it's now become part of the practice SAT test. Now what I'd like you to do is, for those of you that think you can solve this, go ahead and do it. Solve it and show it to me in class. Just title it SAT test practice question. And if you do it, you will get extra effort grades, so that when I do your effort grades, I will remember, I'll write it down, and I'll remember that it was you that solved this. So here's the question. -20, -16, -4, -8. Let's look for a pattern. It looks like it's always plus 4, doesn't it? Okay, because -20 plus 4 is -16. -16 plus 4 is -12. -12 plus 4 is 8, and so on. Now what is the question? In the sequence above, each term after the first is greater than 4. It's 4 greater than the preceding term. Okay, so they're telling us the pattern. Which of the following could not be a term in the sequence? So if you're counting plus 4s, which one of these could not be a number in the sequence? Go ahead and solve that. I would recommend pausing now and solving it if you want to solve it for the extra points. Okay, otherwise let's continue. Alright, example 1. Ramon got a text from Angela. After 10 seconds, he forwarded it to 2 of his friends. After 10 more seconds, those 2 friends forwarded it to 2 more friends. So it looks like it's being multiplied into 2. It's doubling each time, right? If the text was forwarded like this every 10 seconds, how many people received Angela's text after 40 seconds? So after 40 seconds, it means it would be forwarded 4 times, right? Because it's every 10 seconds, 40 seconds. So here we go. The first text was forwarded to 2 people. Those 2 people forwarded it to 2 each, so 4 people, and so on. So it's being multiplied into 2 each time. It's being doubled each time. So you can use a table to track the time and the number of text messages. Okay, so we start with 0 was 1, right? And then after 10 seconds it became 2, it doubled, and after 20 seconds that doubled, and so on. So I'm sure many of you can already figure it out without looking at this, that if it doubles here it'll be 8, and then if 8 doubles it'll be 16, as you have it written there. So 1 plus 2 plus 4 plus 8 plus 16, or 31 people receive the text message. This would be the answer I would be looking for with a therefore statement, as you've learned in the past. So therefore, the 3 dots, okay, 31 people receive the text message. Okay, the next strategy we're going to look at is guess, check, and revise. I'm sure many of you are familiar with this, but here would be an example where we would use guess, check, and revise. Tamiko makes a necklace by stringing beads with the following colors: red, yellow, blue, red, yellow, blue. If she continues in this way, what will be the color of the 50th bead? To solve the other problem, you can make a reasonable guess and then check it in the problem. You can then use the results to improve your guess until you find the solution. This strategy is called guess, check, and revise. So far we have looked at look for a pattern and guess, check, and revise. Page 27. Each hand in the human body has 27 bones. There are 6 more bones in the fingers than in the wrist. there are 3 fewer bones in the palm than in the wrist. How many bones are in each part of the hand? Okay, so here's an anatomy picture of the skeletal hand. This was, here's all the names. This is just something I found online to share with you. Believe it or not, math wasn't my favorite subject in class. It was actually anatomy, kinesiology. And I learned a lot of these names back when I was in high school. I really enjoyed this. So anyways, how can we use math to solve this problem? Well, here we're being told to make a guess to find the number of bones in each part of the hand. So we're going to use the other strategy where we make a guess and we check our work. So here are our guesses, 5, 7, 9, and 8 for the wrist, okay? These are just guesses, and now we're going to actually check our work. And we're using not just guess, check, the guess, check, and revise method. We're also making a table, which is another tool or method that we can use. Now, let's see. Let's explore the information that we're being given, okay? We're being told that there are 6 more bones, right here, there are 6 more bones in the fingers than in the wrist, okay? So, and then there are 3 fewer bones in the palm than in the wrist. So really, we're working with the wrist. And we have to go 3 fewer and 6 higher. The wrist is the number of bones we have to guess, okay? So that's what we're doing right here. So if we start with 5, okay, and we want to get the palm, we know that in the palm there are 3 fewer bones. There are 3 fewer bones in the palm than in the wrist. So we start with the wrist with 5 and we get 2. And then, okay, so right here we have 2 in the palm. And then for the fingers, we said fingers has 6 more than the wrist. So if we have 5, we add 6, we get our 11. Okay, and then the total number of bones would be 5 plus 2 plus 11 equals 18. Yep, this is too low because we need 27. So then we work our way down. If it's too low, let's increase it by 2. It's still too low. It gives me 27 if I follow the rules, right? And I go all the way up to 9, and that's actually too high. We went all the way to 30 by following the rules. I take away 3 for the palm, I add 6 for the fingers, and yep, it's 27, too high. So then I guess with 8. Guess and check, and this is correct, 27 bones. So you notice how we guessed, we checked, and we revised and did it again, and we revised and did it again until we finally got it. Okay, so this is how a table, the guess, check, and revise method work together. Question 2. Colin sold student tickets and guest tickets to a school play. So student tickets and guest tickets. Guests would just be parents and any other relative that wants to come to the play. He sold a total of 154 tickets in all. He sold 8 more tickets. He sold 8 more student tickets than guest tickets. How many of each type of ticket did he sell? So he sold 8 more students than guest tickets. Well, we have to make two numbers, and we have to figure out which ones, and we have to see how students can have 8 more than guest tickets. The way I would do it, boys and girls, is I would start with 154, and I would divide it, cut it in 2. This will give me 77, okay? So really, I can make now 2 groups of 77. Let's say I have 77 students tickets and 77 guest tickets. That's how it would be evenly distributed. So now what I would do is take away enough from the guest tickets until I have 8 more student tickets. Okay? So if I just take 1, right? That's it. I'm only taking 1 away. It would make this number 78, but this number will go down to 76. So in reality now, I have this number has 2 more. Okay? And we would continue on that pattern. And if we continue to do so, we will notice that I actually only had to take away 4. Okay? I only had to take away 4 from the guest pile and add it to the student pile because when I only take away 4, this one's going up by 4 and this one's reducing by 4. So really it's 4 plus 4 to see the difference, which would be 8 is the difference. When you take away from one but you give it to the other, they're getting further apart at double the rate. Okay? If you understand what I mean. You take away 1, so this one goes up by 1 and this one goes down by 1. Okay? So you just have to take away 4, so it could be up by 8. So how many of each type of ticket did he sell? He sold 81 student tickets and 73 guest tickets. Please place a star right there, as this is one of our key answers. So, adding the third skill is make a table. Another strategy for solving problems is to make a table. A table allows you to organize information in an understandable way. There we go. So we have look for a pattern, guess, check, and revise, and make a table. Continuing on to example 3. For example 3, we're going to see how a table can help visualize what we're working with. A vending machine accepts dollars. So you put a dollar bill in there. And each item in the machine costs 65 cents. If the machine gives back only nickels, dimes, and quarters, what combinations of those coins are possible as change from the dollar, from $1? So we have quarters, dimes, and nickels. Quarters are 25 cents, dimes are 10 cents, and nickels are 5 cents. So you would simply just draw it out. You know that 1 quarter and 1 dime gives you 35 cents, so that's one combination with no nickels. And you would continue on. 1 quarter, 2 nickels, that's 35 cents. 3 dimes and 1 nickel, that's 35 cents with no quarters. And there's all your possible combinations right up to 7 nickels. And there's your answer. There are 6 combinations possible. Okay, let's take a look at 3A and 3B. When reading word problems, boys and girls, read extremely carefully. During the SAT, this is something that is always taught and reminded, that you must read these questions extremely carefully so that you know what you're looking for. So here, for example, the product of 2 whole numbers is 36. The product is 36, okay? Meaning when you multiply 2 numbers, you will get 36, right? But now here, what are the possible values for the sum of the 2 numbers? So now you're going to take those 2 numbers that you multiply to get 36, and you have to add the 2 numbers. What are the possible sums? In order to find this out, I'm going to go ahead and make myself a nice factor rainbow. So 1 times 36 is 36, 2 times 18 is 36, 3 times 12 is 36, 4 times 9 is 36, and 6 times 6 is 36. Now that I have all of my factors, I can try to find the sum. If I take the 2 numbers and I add them, find the sum of the 2 numbers. What are the possible sums? Alright, here's one possible sum. Okay? 1 plus 36 is 37. So here's 1. Right? 2 plus 18 is 20. Here's another. 3 and 12 is 15. 4 plus 9 is 13. And 6 plus 6 is 12. Those are all my possible values for the sum of the 2 factors. There you have it. I wrote it a little bit neater for you. Okay, that is also a key answer. So please put a star right there. 3B. Zane paid for a DVD with a $20 bill. The price of the DVD was $19.50. How many combinations of nickels, dimes, and quarters are possible as change for 50 cents? To solve this problem, go ahead and make a table with quarters, dimes, and nickels, okay, like we did with the previous problem. Obviously, these are not the numbers, so please do not copy these numbers. They should be blank. And try to find the combination so that it always equals 50. Don't forget that nickels are 5 cents, dimes are 10 cents, and quarters are 25 cents. Okay, so find every possible combination. There are at least, well, there are, not at least, there are 10 possible combinations. Okay, so don't quit until you get all 10.